Right, I'm going to talk to you about degree of the polynomial. So we looked at the structure of a polynomial in the last video, and here's our structure of the polynomial. Okay? And that's what we're going to use. A sub n, the first non-zero coefficient, it is the leading coefficient, and A sub n times x sub n is the leading term. We're looking at coefficients and terms, same that we did back with expressions and equations, probably 5th or 6th grade. And then n is our exponent. N is the degree of the polynomial, and it is the greatest degree of any term in a polynomial. The one that we're worried about, the one that tells us what is the degree of the polynomial. So again, we'll look at that. All right, so A sub n, x sub n, our leading term. Remember, I told you that in standard form the polynomials should be written with the greatest exponential power of the variable as your first term, and then it should decrease as you go along. So x to the fourth and x to the third. You do not have to have each variable with an exponent, but they should be in a descending numerical order as you go along. And what we will call that exponent is the degree of the polynomial, because it is the largest or the greatest exponential power within that polynomial. One thing I wanted to add though, and our book doesn't really go into this, is that polynomials can have more than one variable. Something like this: 2a squared times b plus 3ab. I have variables of a and b in there. A term containing more than one variable has a degree equal to the sum of the exponents on those variables. So this example here, this would be a degree of 3. 2 plus 1. Again, there's an understood 1 there. So 2 plus 1. We do not have problems with that, but I wanted to make sure that you guys were aware of that. Okay. That being said, let's look at some examples. We start off simple and we move to more complex polynomials. The first one, this is just what they call a constant function. This is simply y equals 5. That is a horizontal line on the coordinate plane at y equals 5. How I need to view it for what I'm doing here with my polynomials is I need to view that as 5 times x to the 0, because what is x to the 0? 1. So that's 5 times 1, which is simply 5. The degree of this polynomial, well, I look at my exponential power, 0. The degree is 0. My leading coefficient, simply 5, and my leading term is simply 5. So my degree was 0, 0 power, leading coefficient 5, leading term 5. And I'm going to go ahead and slide these off for the next one so that way you can see. Again, we have a linear equation, binomial. I look at my power, there's an understood 1 there, so that's my degree, 1. So I have a degree of 1. My coefficient is 2. My term is simply 2x. For this one, my degree is going to be what? 2. My leading coefficient, negative 3. My leading term, negative 3x squared. Okay? So 2, negative 3, negative 3x squared, negative 3x squared. The last one, first thing I look at and I see it is this is not in standard form. So what is the degree of that polynomial? The degree is 3, x cubed. That's the highest exponential power of any of my terms. The leading coefficient is 1, because there's an understood 1 with the x cubed. And what's my leading term? X cubed. Excellent. Simplistic, but important. So, some things, those little rules, how things work out. Polynomial functions, whenever you have f of x equals 0, it has no degree. And remember, I told you some functions are not polynomials, and we had the guidelines that the coefficients had to be real numbers and our exponents had to be whole numbers. Well, the primary example you're going to look at in what we did with rational functions and radical functions, those are not considered per se polynomials. This is because 3 over x squared minus 1, I can rewrite that x squared is actually x to the negative 2. Negative exponent, not a whole number. And same here, is whenever I rewrite the radical as an exponent, the square root is the same as the exponent of 1/2. Not a whole number, it's fractional, it's a rational number. So, here are some examples, 1, 2, and 3. I want you to determine the leading term, the leading coefficient, and the degree. Pause the video and go ahead and answer those. Alright, so my leading term is 3x squared. Leading coefficient is 3 and my degree is 2. Leading term, 4x to the 6th. Leading coefficient, 4. Degree, 6. My leading term, well, this is not written in standard form. This right here, and I could rewrite it all and make it in standard form, but this right here is my leading term. A negative 5, x to the 4th, leading coefficient, negative 5, degree, 4. Alright guys, that's how to determine the degree of the polynomial. Please continue to watch your publisher videos on the example homework problems. Read your textbooks. Structure and critically think about your homework. And if you have questions, then please get with me and ask. Thank you.